Hi guys, in my previous video we had talked about detecting EMF in standard conditions. And what were those standard conditions? It was 1 atmosphere pressure, 298 Kelvin and 1 molar concentration. Why should always EMF be in standard condition? So in this video we'll be talking about how to detect EMF in non-standard condition, and that is what is Nernst equation. Let's try and understand Nernst equation first, and then also try and solve a numerical to get it still better. Alright, so let's get into it. Alright, this is what is Nernst equation. And now in Nernst equation, A plus B gives you C and D, where A, B, C, D are moles of reactant and product. Alright, okay. Now the Nernst equation is E cell. Mind you, there's no zero because this is non-standard condition. It requires standard condition. Alright, so EMF of standard condition minus RTNF ln concentration product of concentrations of products with their moles as power divided by product of concentration of reactants with their stoichiometry or moles. Alright, so this is what is Nernst equation. But don't you think this also is equal to K, equilibrium constant? Fine. So this can also be written as E cell is equal to E0 cell minus RT NF ln K. Alright, okay. Let's first get into the better format of Nernst equation, or rather simpler format of Nernst equation. Now see, so what do we do? E0 cell, same thing, E0 cell. Now ln is log to the base E. Now we have got to convert that to log to the base 10. So for converting, what do we do? What is the converting factor? Converting factor is 2.303. So once if I multiply with 2.303, ln gets converted to log to the base 10. What's the advantage? Once we get this in terms of log to the base 10, then we can refer our log book. All those values, whatever are there in our log books, are all log to the base 10. Okay? Alright, so we did that. Now we have got to substitute R. We know R is gas constant, this is the value. We have got to substitute T, temperature, ambient temperature 25 degrees Celsius plus 273. So that comes to 298. Alright, 298 Kelvin because temperature is taken in Kelvin. Then N is number of moles, number of electrons that's involved in reaction. Now for example, we did reaction with CO2. We did for example, we did reaction with zinc, copper sulfate, giving you zinc sulfate and copper. We did that reaction, right? In that exchange of electrons were how many? 2. So that 2 is this 2, number of moles of electron. Now 1 mole of electron corresponds to 96500. So just number of electrons won't do. We are interested in Faraday. How many Faraday? So in that case it would have been 2 into 96500. Fine. Okay. So F is Faraday, N is number of electrons. Alright, number of moles of electron rather. Alright. Now when we substitute these values, F 9650, T 298 Kelvin, R 8.314. So what R, T, N, F substituted along with 2.303 already substituted. When we calculate this, the value that we get is 0.0592 divided by N. Now N, why did we not substitute N? We did not substitute N. Why did we not substitute N? In every reaction, exchange of electrons would be different. So N would be different. So we kept N as it is. And this part remains as it is. Alright. Now, got it? So our formula which was there for Nernst equation got modified to this. So now our E cell would be Okay, so this already I mentioned how do we calculate E cell in my previous video. So we calculate it that way. That is what is standard state. What do we call this? We call this as correction for non-standard state condition, because now we have done this in non-standard state condition, so we have got to apply correction. So this is known as correction for non-standard state conditions. All right. Before we get into numerical, an interesting one of course, we have got to keep one thing in mind. There is a law. The law says concentration of pure liquids and solids are taken as unity. All right. Now suppose in that reaction that we did, now what we did was we took zinc plus copper sulfate, giving you zinc sulfate and Cu. Now if I write it in terms of ion, it would be Zn plus Cu2 plus, giving you Zn2 plus Cu. So this is solid. So I am just writing this part, right? So it would be log to the base 10, right? So I would be writing here concentration. So concentration of product, concentration of product of it. All right. So product is what? Zn2 plus concentration I'll write, and I would also write concentration of Cu solid. And here reactant is Zn solid. This was solid. This plus is for this plus. This is solid, and sorry, it has to be box. I hope you are aware that box is what is concentration. All right, so we have got to put it in box bracket always. All right, and Cu2 plus. So this, as per this rule, this is what? Solid. So this would become 1, and this is also solid. All right, these are solids. So this would also become 1. So our equation would be log to the base 10 Zn2 plus concentration of course divided by Cu2 plus. Got it? So this is one thing that we have got to keep in mind. And also for pure liquids it would be 1. Alright, this is one thing that you have got to keep in mind when we are progressing for numerical based on Nernst equation. So now let's get into the numerical. Okay. So guys, having understood Nernst equation, now let's get into numerical and understand it still better. Okay. Happy viewing.